and 3. So there are 4 linear pair when this situation happens, when you have 2 lines that intersect, forming those 4 angles. So let's move on. It says, reason quantitatively. Explain why the angles you just named in part A, so we're talking about angle 3 and angle 5. Those are the 2 angles that we deem to be supplementary to 4. Explain why those 2 angles, angle 3 and angle 5, must have the same measure. So why must the measure, this is what we're trying to prove here, the measure of angle 3 equals the measurement of angle 5. And so I'm going to put a little question mark above that equal sign, because that's what we're trying to figure out. I mean, are those equal? So we can, I'm going to do a proof. I'm going to prove this, but let's just talk about it. So since we stated up here that 3 and 4, their measures sum up to be 180 degrees because we recognize they're a linear pair, well, and then we also said that angle 5 and angle 4, since they're a linear pair, they add up to be 180 degrees. Well, those 2 equations, one's written over here, one's written over here, they have a couple things in common. A, you're adding 2 angles up, and you're adding 4 both times. 4 is common in both equations. So this measurement's not going to change. Whatever the measurement of angle 4 is, this is going to stay the same. It's going to stay constant. And these both add up to be 180 degrees. So whatever 5 is to make the sum of angle 5 and angle 4 180, well, since 4 is not going to change, it's going to take the same amount of degrees to equal 180 when you add 3 and 4. So since 4 is not changing, that angle is going to stay the same, and these 2 sums have to equal the same number, 180 degrees, then they must be the same, because you'd have to add the same number to 4 to get 180. So that's just kind of us talking about it, and so I hope that makes sense a little bit. If not, you can just pause the video and just think about it, and maybe write some things out and say, you know, if these 2 have to add up to 180, and so do these 2, and they have a common factor of angle 4, well, that's angle 4 is not going to change. So you have to add the same thing both times to angle 4 to get to 180. So like I said, I'm gonna do like a formal proof, and we talked about this in class. Kind of told you that, hey, proofs are coming, and this is an example of a 2-column proof. On the you have 2 columns, 1 and 2. On the left-hand side, you have your statements, and then you can't just say statements for any old reason. You must have a legit reason. So whenever your parents say go clean your room, you say why, and because they say I told you so. That doesn't work in geometry. You can't just say because because I said so. Like, that doesn't work. You gotta have legit reasons, appropriate postulates, properties, theorems, and so those are your reasons, or all these theorems and properties and different new terms and so on and so forth. That's going to be all of our reasons over here. So in a proof, you're always given some sort of information. You're always given some sort of information. So what our given information is this diagram. We are given this diagram, and we need to recognize what's happening in this diagram. The fact that 3 and 4 are a linear pair, and angle 4 and 5 are a linear pair, so on and so forth. So we need to recognize that. And then we were asked to prove this, that the measurement of angle 3 is equal to the measurement of angle 5. So when you're doing proofs, you always start with some sort of given information, and then you work your way down to prove another statement. So your prove statement will always be the last thing you say, because that's what you're trying to do. You're saying, hey, I'm given this, and I'm going to work, and I'm going to convince you, I'm going to prove to you that this is true. This is going to be my last statement. So you always start off with what you know. So number 1, I'm going to start off with what I know. This is my given diagram. I know that the measurement of angle 3 plus the measurement of angle 4 is equal to 180 degrees. Now, traditionally you would start off and you'd say, hey, angle 3, angle 4 are a linear pair, and then since they're a linear pair, then the measurement of angle 3 plus measurement of 4 is equal to 180 degrees. So I kind of combined two steps, but this is just an example. When we get to proofs, we'll really dive into them. But I know that the measurement of angle 3 plus the measurement of 4 is equal to 180. And so I'm going to say linear pair, linear pair always supplementary, right? Item 2, we also know that there's another pair of angles that are supplementary. You have angle 5 and angle 4, and it's for the same reason. My reason for statement 2 is same thing. Linear pair are always supplementary. Item 3 from here, I'm going to do a little bit of algebra. Since I have two equations, I know that this expression, the measurement of angle 3 plus measurement of 4, is equal to 180. And also in my second equation, this expression, measurement of angle 5 plus measurement of angle 4 is also equal to 180. So I'm going to do a little bit of substitution. And I'm going to take this expression that is measurement of angle 5 plus measurement of 4, which equals 180. I'm going to sub it in place of that 180. So my first equation, my first statement, measurement of angle 3 plus the measurement of angle 4 is equal to, I'm not going to write 180 anymore, I'm going to substitute and write the measurement of angle 5 plus the measurement of angle 4. And what allows me to do that? It's substitution. Substitution, that's a little bit of algebra for you. From there, item 4, if we look at this statement here, this equation, we notice that there is something in common on the left-hand side and the right-hand side, and which is in common is the measurement of angle 4. So, both sides of the equation, I'm going to subtract the measurement of angle 4, and I'm going to subtract the measurement of angle 4. And we've done that in algebra, we've done that in the first couple of weeks of school, and we're allowed to subtract the same exact thing from both sides of the equation. Because remember, like I said earlier, if you have this symbol, the M in front of the angle, that means we're talking about some numerical value. We don't know what that numerical value is, but we know it represents something like 66 or 37 or 42 degrees. It's a number, so we can add and subtract numbers. So my new statement is going to be the measurement of angle 3, well, the measurement of angle 4 minus itself, that's 0. So we're just left with measurement of angle 3. And then on the right hand side, we've got measurement of angle 5, and then same thing. This minus that is 0. And so look, we have arrived to our prove statement. It's what we're trying to prove. And the way we got here, the way we got to item 4, was we subtracted the same thing on both sides of the equation. And what allows us to do that in algebra is the subtraction property of equality. So there you have it. There's no way anyone could argue with this with this proof. Now, no matter what, these two angles must have the same measure. So, a lot going on there. Please understand what linear pair are, and recognize that whenever this happens, you're going to have 4 linear pair, and then also that you're going to get these angles that are opposite of each other that have the same measure. I hope that it's not a difficult thing to grasp that if 3 and 5 are the same exact measure for the reasoning we just followed, then if you follow that same logic, 4 and 6 must also have the same measure. And that is a true statement. These pairs of opposite angles formed by two intersecting lines, they have a special name. They're called vertical angles. Okay, and vertical angles are they're the opposite angles formed by two intersecting lines. Let's go and write that. They are opposite angles formed by two intersecting lines. They are the opposite angles formed by two intersecting lines. And, extremely important, I'm going to put a star, they are always congruent. We haven't talked about that word yet, but what that means is same measure. They have the same measure. Two angles that are congruent have the same measure. Whenever you have this diagram of two lines intersecting, there's always going to be two sets or two pairs of vertical angles. Okay, because there are two sets of opposite angles. Vertical angles are always congruent. So in this diagram, you got linear pair, you got supplementary angles, you've got adjacent angles, you got vertical angles. There's a lot going on in this diagram, so please be aware of those things.